All right, let's get started on our lesson. Okay, so we are talking about arithmetic and geometric number patterns. All right, so what we need to be able to do in grade 7 is describe patterns, extend them by 2, 3, 4, maybe even 5 terms, just depending on what they ask us to do. And they also want us to be able to find the rule for a term, but we're not going to do all of that today. What we're going to do today is we're going to look at the difference between arithmetic and geometric number patterns, and then we're going to look at some number patterns together, and we're going to see how we would find what the next term is, whether we are adding or subtracting, or whether we are multiplying or dividing. Okay, so when we talk about a number sequence that has a constant difference, let me just highlight that word for you in yellow, a constant difference, right? We are talking about number patterns where you either have to add or subtract the same number to move between two consecutive terms. Do you know what the word consecutive means? Does anybody know what the word consecutive means? Okay, so let's see who's got a hand up. So hands up if you want to talk, please. Okay, Tertia, you put your hand up first. What does consecutive mean, Tertia?
Ma'am, sorry, my hand was up a long time ago. I forgot what I wanted to ask. It was not for consecutive.
Oh, okay, so not for consecutive. Do you know what the word consecutive means?
Not a clue.
Okay, well then it's a good thing that we decided to discuss it. Okay, so I'm going to have a look at the next person who's got a hand up, and that's Yelwa. Do you know what the word consecutive means for Yelwa?
No, ma'am.
No, okay. Well, then I'm glad I asked the question. What about Tahila? Do you know what the word consecutive means?
Ma'am, the only idea I've got is that doesn't mean like continuously.
You're on the right track, Tahila. You're definitely on the right track. So when we talk about consecutive numbers, we're talking about one that follows the next. So if I give you 3 consecutive numbers, I could go something like 3, 4, 5. Or I could go 99, 100, 101. Okay, so the word consecutive means that they follow one another. And we can have numbers that are consecutive, but we could also have consecutive even numbers and consecutive odd numbers, all right? So consecutive even numbers would be something like 2, 4, 6, 8. Consecutive odd numbers could be something like 5, 7, 9, 11, 13. Okay, so consecutive in English means that they follow one another. Okay, so one term follows the next. Now I see there's people that have got hands up. Do we need to ask questions? Is it okay? Okay, and how to pronounce your name? Is a hand up? No? Okay, all right, let me continue then. All right, so patterns that have a constant difference, you would either add or subtract the same number to move from one term to the next. So if we have a look at the number pattern that I've put on the board, we've got 1, 4, 7, 11. So we would consider 1 to be the first term. 4 is the second term. 7 is the third term. 11 is the fourth term. Okay, so those are the consecutive terms. They follow one another. And in this situation, there is a common difference of 3, which means that each time I move from one term in the pattern to the next term in the pattern, I need to add on 3. All right, so because I'm adding 3 each time, that makes this an arithmetic pattern. There is a constant difference. So our constant difference can either be a positive or it can be a negative number. If we have a look at the pattern below, it goes 2, -3, -8, -13. Now, we've just finished a course where we've been speaking about integers. So we understand where -3 is on the number line and where -8 is on the number line and where -13 is on the number line. Can you see as we move from one term to the next, we are taking away -5. So we have a constant difference or a common difference of -5. Did someone talk to me? No?
Ma'am. So what you mean is that consecutive means that you're following each number continuously.
Correct. So there is going to be a pattern there. Okay, so 1, 4, 7, and 11 would be seen to be consecutive terms when there is a difference of +3. Okay.
Yes,
All right, and the pattern starts at 1. Okay, Patson, you've got your hand up. What's up, Patson?
Ma'am, for the first explanation, ma'am, it's wrong. Like, for after 7, ma'am, it's not 11, ma'am, it's 10. I think it was a typing error.
Oh, it is a typing error. Sorry, you're quite right, because we're adding 3. Sorry, thank you, Patson. Quite right, that should be a 10 because we're adding 3 every time. Correct. And then the next one would be, the next number in the pattern would be?
The next number would be 13.
Absolutely, and then 16, and then so onwards. Thanks, Patson. That is a typing error. All right, thank you for pointing that out. I hope I didn't make any errors in the second one. No, that's fine. That's fine. Okay, so when there is a number that we are adding or subtracting, and it's the same number each time between consecutive terms, we say that we are working with a linear or an arithmetic pattern. Okay, but these are not only the kinds of patterns that we would have to look at. We also need to look at patterns that are called geometric. Now, in the case of a geometric pattern, there is not a constant difference. So here it means that you will find that there is what we call a constant ratio. All right, so what this really means is that we have to multiply or divide the same number between consecutive terms. So if we have a look, if we've got 2, 4, 8, 16, that shouldn't be 24, should it? Lots of typing errors here today. That's no good. That should be 32. All right, we are multiplying by 2 each time. All right, so that means that this is going to be a geometric sequence. All right, and then here I corrected my error, but I've moved it, so I'm just going to rub that out. Right, this was supposed to be -9. So in the next pattern, we've got 3, -9, 27, -81. So each second number, each second term in the pattern, right, is going to be a negative number. So that means we must be multiplying by a negative in this case. All right, remember, a negative times a negative gives us a positive, and a negative times a positive gives us a negative. So we're multiplying by -3 each time, and that's why it goes positive, negative, etc., etc. Let's have a look at another example. Okay, so here we can also divide. Sorry, this is not times, it's divide. So we can also divide by a number. So in this case here, we are dividing by 3. Okay, so we're saying starting with 3, dividing it by 3 and getting 1, taking 1, dividing it by 3 and getting 1/3, taking 1/3 and dividing it by 3 and getting 1/9, etc., etc. All right, so here you have to divide by 3, not -3, to get to the next term. Okay, so this would also be an example of a geometric sequence. All right, so any patterns where you need to multiply and divide are called geometric, and ones where you would need to add and subtract are called arithmetic patterns. So it's going to be important to you to look at the pattern of numbers once you've been given that, and then decide what the next number in the pattern needs to be. All right, so let's go and have a look at some examples, okay? And there's be a couple of things here that I hope you haven't seen before. All right, so now I'm going to call on, let's see, Basetsana. Okay, so Basetsana, I want you to have a look at 1A, and I want you to tell me what you think is going on here, so the relationship between the consecutive terms, and could you tell me what the next 5 terms in this pattern would be? Basetsana?
I would like to do it, ma'am.
Okay, Tatum. You do it then, Tatum. That's fine.
Must will say 100 minus 5 will give us 95. 95 minus 5 will give us 90. 90 minus 5 will give us 85. 85 minus 5 will give us 80. 80 minus 5 will give us 75. Then we get 70.
Good, Tatum. And then we would
65.
have? Good. And then?
Then 60.
That's very good, Tatum. Well done. Okay, that's excellent. Perfect. Okay, now. All right, so hang on a second. I see what is arithmetic. Okay, hold on a moment. I just need to answer a question here. Okay, so a constant difference means that we are adding or subtracting the same number each time. All right, now if we have a look at the second one, I'm going to see who's got their hands up here. Let's find someone with their hand up. Okay, Rolivua, I see you've got your hand up. Rolivua, what's going on in pattern B?
You are adding 0,2 each time.
Absolutely. So would this be an arithmetic pattern or a geometric pattern?
Arithmetic.
It would be an arithmetic pattern. Quite right. It would be arithmetic. And can you tell me what the next 5 terms in the pattern would be?
Yes.
Sure, go for it.
Is it 1.1? 1,3.
Good.
1,5. 1,7 and 1,9.
Lovely, Rolivua. That's perfect. Good job. Very nice. Okay, so now you guys are super, super clever. These are there's some more here that are a little bit more difficult. Let's talk about what's happening in number C. Yes, Anati.
Can I please do H?
Okay, Anati. When I get down there, I will try and remember to let you do H. All right, so let's see who's got a hand up. Okay, Motiban, can you do C?
I'll try, ma'am.
Okay, Motiban.
Ma'am, I think this is a geometric pattern.
You are quite right. It is a geometric pattern. And what makes you think that it's geometric?
It's because it doesn't. Oops.
Because
no, I don't think it's a geometric pattern because.
Don't you think so?
I don't think so because it doesn't repeat.
I think that you were right. And I think that what you need to do is look at the 6 and look at the 18, and then look at the 18 and look at the 54. Okay, it has to be geometric because there isn't a constant difference. So the numbers are getting bigger. So we're probably multiplying. What do you think we're multiplying by to go from one to the next?
3.
I agree with you, Motiban, because 6 times 3 is 18, isn't it? And 18 times 3 is 54, and 54 times 3 is 162. Oh, now, well, I tell you what, let's not maybe do the next 5. Let's see if we can do the next 2 terms. Okay, so what would the next 2 terms be, Motibang?
2 times 3.
What are you going to multiply? Go for it.
I'm trying to think.
Okay. Remember, as we go from one term to the next, we are timesing by 3. So to go from 162 to the next term, you've got to times by 3, Motibang.
Okay, ma'am, I'll try.
Okay.
162 times 3. 62 times 3.
So you'd say 3 times 2 is 6. 3 times 6 is 18, carry 1. 3 times 1 is 3, plus 1 would be 4. Okay, so it would be 486.
Sorry, ma'am.
Exactly.
Sorry, ma'am. I can't think. I was about to say let
Okay.
someone do it.
Oh, it's all right, Motsibang, not to worry. Okay, and if we had to times by 3 again, grade 7s, we would end up with 1,458. Okay, but those numbers are quite big. I think it would be a little bit difficult. Okay, Olutando, you've got your hand up. Can you tell me what's going on in the next pattern?
Ma'am, they're going twice. Wait, they're going plus 1 of every number. Every time they skip, they plus 1.
Okay, so in other words, from there to there, we had to plus 2. From here to here, we had to plus 3. From
3,
here
yeah.
to here, we had to plus
4.
4. From there to there, we had to plus
6.
5 to get to 15.
5, ma'am.
Okay, so what do you think the next number is going to be?
It's 21.
It's 21. Good. And what's the next number after that?
28, ma'am.
Good. And then after 28, what would you add to 28?
37. It would be 9, ma'am.
Yes, it would be. And so onwards and so onwards. Now, I want to ask you, what sort of pattern do you think this is? Do you think it's geometric or is it arithmetic?
I think it's arithmetic.
Okay, but with an arithmetic pattern, it has to be the same difference every time. So in other words, if I'm adding, I've got to add the same number every time, or if I'm minusing, I've got to minus the same number every time. So do you still think it could be arithmetic?
No, ma'am.
No. Okay, this is a trick question, Olutando. And do you think it could be geometric? Are we multiplying by the same value each time?
No, ma'am.
No, we're not. Okay, so this is neither. It is neither geometric nor arithmetic. All right, you'll learn about these patterns when you get to grade 11. Okay, they're actually called quadratic patterns. But it's nice just to be able to talk about things like that. Okay, so it's neither geometric nor arithmetic because there is no constant difference and no constant ratio. Okay, let's see who else has got a hand up now. Kia Mogetswe. Do you want to do E for us, Kia Mogetswe?
Yes, ma'am.
Go for it. What's happening in this pattern?
Ma'am, we're adding 11.
Every time?
Yes, ma'am.
We certainly are. So if you added 11 to 53, what would you get?
Ma'am, 64.
Lovely. And if you added 11 again, you would get?
75.
Lovely. Okay, so what sort of pattern is this? Arithmetic, geometric, or neither?
Ma'am.
What do you say?
Ma'am, I think it's geometric.
Okay, but if it's geometric, then you've got to be multiplying or dividing. Okay, multiplying or dividing. So this can't be a geometric pattern because remember you said, and correctly so, that we are adding 11 each time. So if we adding 11 each time, there's a constant difference of 11. So that means that it is an arithmetic pattern. Okay, arithmetic. All right, good job. Well done. Okay, now we're going to have a look at the next one. Okay, question F. Let's see who's got a hand up. All right, Joshua. Joshua, do you want to do F for us?
No, ma'am. I'm sorry. It was a mistake.
Okay, all right. That's fine. You sure you want to try?
No. Sorry,
Okay, that's fine. I see Fatima, you've also got your hand up. Would you like to try?
We're subtracting 0,3.
We're subtracting 0,3. Good, Fatima. So tell you what, extend the pattern by 3 terms for me.
Eight, 8.
Good, well done. And then the next one would be
8,5.
lovely. And then the last one?
8,2.
8,2. Whoopsie, comma 2. Good. And what sort of pattern do you think it is? Arithmetic, geometric?
Arithmetic.
Arithmetic. It's arithmetic because we are subtracting 0,3 each time. Good, Fatima. Well done. Perfect. Okay, now 18,000, 1,800, 180, 18. What on earth is going on here? Let's see who's got a hand up. Poliswa, what's happening in question F? Sorry, question G.
I think your mind is saying you're dividing by 18.
You're dividing by 18. Okay, but
no, you're dividing by 10, sorry.
You divided by 10. Okay, can you see a 0 is disappearing off the end each time? Okay, so quite right, we are dividing by 10. So
yes.
now the questions become difficult. I want you to extend this pattern for me by 2 numbers. What am I going to write next?
0.
You're dividing by 10, so what's going to happen? You've got the number 18.
Oh, 1.8.
That's it. So you're going to get 1.8. Good. And now you're going to divide that by
10. Which will be 0,18.
Very good. All right. And do one more.
0,018.
That's lovely. Well done. Very nice. And is this arithmetic or geometric?
Arithmetic.
Why is it arithmetic? If it's arithmetic, it means there is a constant difference. So a constant difference means that if we're getting smaller, we have to be minusing the same amount every time. Are we minusing the same amount every time?
No.
No. Remember we said we were dividing by 10, didn't we?
Yes.
Okay, so if we're dividing, then it means it has to be a geometric pattern. Okay, so G is geometric. Okay, because we are dividing by 10 each time. Now, I can't remember who it was. Someone said that they wanted to do question H.
It was me, ma'am.
Okay, Anati. All right, so what's happening here each time, Anati?
We're dividing in 2s.
We're dividing by 2. Good, Anati. Well done. That's very good. Okay, so now extend the pattern for me. By 3.
1. It's going to be 1.
Uh-huh.
And then 8.
1 over 8.
No, it's going to be 1, 8, 80.
Hang on a second. Sorry, Anati. If we've got 1 over 48, and then 1 over 24, and then 1 over 6, all right? We've divided by 2 to get here. Then we
Then we're going
couldn't
to
have
divide
divided
by
by
4.
Okay, are we dividing by 2 or are we dividing by 4? Is there a mistake in this pattern? Because 24 is half of 48, but 6 is not half of 24. I think this was supposed to be a 12. Okay.
It's supposed to be a 12 because now it's like we dividing by 4.
Yes, exactly. Okay, so let's just change that to a 12. Okay, Anati, take it away. What's the next two numbers got to be?
1/3.
Remember we're dividing by 2? Okay. So it's got to be 1 over?
One over 3.
So we've halved 48, we've halved 24, we've halved 12, so that has to be 6. 1 over 6. Okay, that's it. And now we've got to halve 6, and then it would be 1 over
3.
Good. Okay, and because you were dividing by 2 each time, that means that this is a geometric pattern. Good, lovely, very nice. Okay, excellent. Okay, Jody. Do you want to do I, Jody?
No, ma'am, I just had a question for G.
Okay, do you want to ask a question?
But it's fine.
You sure?
I understand it now, so it's fine.
Okay, all right,
Yes, ma'am.
no problem. Okay, 100%. All right, Asimahle, do you want to do I for us, Asimahle?
Yes, ma'am, but like I can't explain how the pattern goes. Like,
It's a strange one, isn't it?
yes.
Okay, so tell you what. Let's have a look at what's going on here, Asimahle. We got 1, we got 4, we got 9, we got 16. All right. So between 1 and 4, there's a difference of 3, isn't there? And between 4 and 9, there's a difference of
5.
Good. And between 9 and 16, there's a difference of
7.
Good. So what number do you think you need to add onto 16 to get the next number in the pattern?
9.
Okay, so if you say 16 plus 9, what's the next term in the pattern going to be?
25.
Indeed it is. And what do you think you need to add onto 25 to get to the next one?
11.
And what would you end up with?
36.
Absolutely. Now, these numbers here are very important numbers. Does anybody know what they're called, this particular number pattern? It has a name. Does anybody know what the name is?
Ma'am,
Who's calling me?
this is counting in ones.
No, we're not counting in ones, because if we were counting in ones, we'd say 1, 2, 3, 4, etc., etc. So we're not counting in ones because each time we add, we're adding on 2 more than we added previously. Okay, so these are very special numbers for us. Let's see who else is. Pardon, Fatima? Okay. Iola, do you want to say what you think these numbers are?
Ma'am, are they odd numbers?
Well, the numbers at the bottom are, the numbers that we're adding each time are odd, but, you know, the numbers at the top are not necessarily odd. They go odd, even, odd, even, odd, even. Who's saying ma'am, ma'am?
It's me, ma'am. It's Ayola,
Okay,
ma'am.
all right, Iola.
I just want to say, like, I don't see anyone. I just see, like, it's blank.
Oh, really? Can you not see anything?
Yes, ma'am. I just, like, see, like, it's blank and just, like, the names, like, Patricia and Matavong. That's the only thing I see.
Oh, my word. No, we've got a whole thing going up here. So I think what you need to do, Iola, is log out and log back in again.
Okay, ma'am.
Okay, because something's definitely not correct there. Okay, you should be able to see what everybody else is saying. Okay,
Okay, ma'am.
Tyler, no problem. Tyler, what do you think these numbers are called? Have you
Hello,
seen
ma'am.
them before?
Ma'am, are they geometric patterns? I mean numbers. No, sorry. They're multiples.
Multiples of what, Tyler?
Ma'am, I'm not too sure.
Okay, so unfortunately they're not multiples, but that was a good suggestion, right? Masizazi, what do you think?
I think that I just totally don't understand. Like the numbers keep increasing.
Yeah, they do. They do keep increasing. And these are very important numbers for us. You're going to be working with these numbers a lot when you get to high school. So I'm going to ask one more person.
Yes, ma'am.
And then I'm going to tell you. Okay. So Rolivua, you've got your hand up next. What do you think?
I feel like they either cube numbers or square numbers.
Oh, there we go, Rolivua. I just had a feeling that you might know. That's wonderful. Well done. So what's the difference between square numbers and cube numbers, Rolivua?
With square numbers, you multiply a number by itself, and with cube numbers, you multiply a number by itself and itself again.
Oh, wow. That's a really wonderful explanation, Rolivua. Thank you very much. Perfect. All right. So square numbers are called square numbers, grade 7s, because they literally actually make squares. Okay. So the smallest number that we can multiply, or natural number that we can multiply by itself, is 1. So 1 times 1 is 1. Okay. Then what we can do is we can multiply 2 by 2. 2 by 2, and there we end up with 4. Absolutely. And then we can multiply 3 by 3. 3 by 3, and that's how we end up with
9.
9. Absolutely. So can you see, grade 7s, that square numbers actually make squares? How cool is that?
Ma'am.
So it's not just called square numbers for no reason. They're called square numbers because they actually make squares. So this one, 4 by 4, and that's where the 16 came from. Okay, so 1, 4, 9, 16, 25. Those are the square numbers. All right. So in other words, we're taking a number, we're timesing it by itself, and that's where we're getting our pattern from. Well done, Rolivua, for picking that one up. That's really great. But you said something else that I thought was super interesting, and you spoke about cube numbers. Okay, so if square numbers mean multiply something by itself, what does a cube mean? Rolivua told us.
Your screen.
Try logging out and logging back in again. You should be able to see the screen. Okay, Anati, what do you think cube numbers would look like?
1 times 1 times 1.
Lovely. So what's 1 times 1 times 1?
1.
Absolutely. So 1 by 1 by 1 gives us 1.
1.
Good. Absolutely.
2 times
Right.
2 times 2.
Absolutely. And 2 times 2 times 2 leaves us with
8.
Indeed. Okay, so 2 by 2 by 2
Gives us 8.
leaves us with 8. And
8.
what's 3 by 3 by 3?
27.
That's it. So 3 by 3 by 3 would be 27. And the next one would be 64 and so onwards. Absolutely. So these are called, yes, exactly. So these are called cube numbers. Absolutely. They're called cube numbers. Okay, so square numbers make squares and cube numbers make cubes. Absolutely. And you know what else? I want to show you something. Let me go back up to this pattern that was up here. You see this pattern 1, 3, 6, 10, 15 that we were talking about where I wrote in green? Now look at this. Look how cool this is, all right? So that pattern went like this. It went, let's just move over to the side. Okay, that pattern went.
Excuse me, ma'am.
3. Yes, Joshua.
Are we supposed to be writing this?
No, you don't need to be writing this. You don't need to be writing this. We're just talking. There's going to be stuff for you to write in a little bit, but you can write it if you want to. You can make notes. Thanks,
ma'am.
That's up to you. Now look at this, grade 7s. So what I'm going to do here is I'm going to make one little dot. And here, I'm going to make 3 dots. And here, what shape am I making, grade 7s?
Triangle.
Yes, look at that. So there you go. So we've got numbers that make squares, numbers that make cubes, and then we've also got numbers that make triangles. Did you know that? Did you know that numbers could make triangles?
No, ma'am.
You didn't? Okay, well then I'm glad I told you this. Yes.
Ma'am.
Yes. Yes, Toyiswa?
For the 3 dots, doesn't that mean therefore?
It does. If you write this in maths, it does mean therefore. All right, but I'm just using, it could be anything. It could be 3 blocks. It could be 3 stars. It could be 3 letters. It doesn't necessarily have to be 3 circles. I'm just using that to show you how this number pattern makes triangles. Okay. I think that's pretty cool. All right, so now where were we? We were talking about this pattern over here. And we said that these were square numbers. So the next one would be 25 and the next one would be 36 and so onwards and so onwards. Now let's have a look at J. Who's got their hand up? Okay, I'm going to call
I think dividing by 5.
Okay, so we're dividing by 5 each time. All right, 100%. So we've divided by 5 to go from here to here, and we've divided by 5 to go from there to there. So what's the next number in the pattern going to be, Anda? Five divided by 5 is 1. Okay, and then if we had to divide by 5 again, we would end up with 1 over 5, wouldn't we? Yes, absolutely. And then what would we get after that?
0.5.
0.5? You sure? If I take 1 over 5 and I divide it by 5?
Then is it 1 over 25?
It is. Okay, so remember when we work with fractions, we have to tip and times. Okay, so dividing fractions means tip and times. 1 times 1 is 1 and 5 times 5 is 25. So absolutely it would be 1 over 25, etc., etc. So is this arithmetic, geometric, or neither? It has to be? Okay, Pabalo, what does it have to be? Pabalo?
No,
if I'm dividing by 5 each time, it means it has to be a geometric pattern. Okay, it's going to be geometric because I'm dividing, all right, by the same thing each time. Okay. All right, so now here's an opportunity for you guys to do this, all right? So when they say write the rule, right, I'll do an example with you, and then you guys can try this on your own. Let's just get rid of that. Okay, so let's do the first one together, okay? So the first number is 5, the next number is 20, the next number is 80, the next number is 320. What do we think we are doing each time here? Masizazi, what are we doing?
Dividing by 4.
Dividing?
By 4.
Okay, but are we multiplying, dividing, adding, or subtracting?
We I think we are dividing.
Okay, but the numbers are getting bigger, aren't they? So we've gone from 5 to 20 to 80. So
we are multiplying.
We are multiplying, absolutely. So if I take 320 and I multiply it by 4, what am I going to get? Do you know?
320 multiplied by 4.
Do you know how to calculate that?
Just a second, ma'am.
Okay.
Okay. Ma'am said 320 divided by, multiplied by 4. 1,280.
That's it. Quite right. Okay, so 1,280. I tell you what, work out just the next one. So you're going to take 1,280 and you're going to times that by 4 as well. What are we going to get?
Okay. It's 5,120. 5,120.
Absolutely. Okay, and if we had to say you had to write the rule, what would be the rule?
I think it would be multiplied by 4.
Multiply by 4. Good. All right. Okay, so now I'm going to be quiet and Kat's going to be quiet, and we're going to let you try B, C, D, and E if you manage to. Okay, you might not quite get that far, but let's just see what happens. So Kat and I are going to be quiet for 5 minutes, and we're going to let you guys work, and then we're going to mark our work. Okay. Aziza, you got a hand up? What's wrong, Aziza? Tahila, you've also got a hand up. What's up, Tahila? We will do the poll later today. Okay, so you guys try and answer this. You can extend by 3 terms and then write down what you think the rule is. Okay.
Ma'am?
Yes, Tahila.
Ma'am, can you please move it up a bit?
Sure.
Thank you, ma'am.
Is that better?
Ma'am.
Let's try and make it a bit bigger. How's that?
Ma'am, there isn't a change on my screen.
Okay, I have made it bigger. Maybe it'll take just a second to come through. Sinotando?
Yes, ma'am.
What's wrong?
Ma'am.
Yeah.
Ma'am, what activity should I be doing?
So it's the one that's in the middle of the screen at the moment, okay? So it goes in A, it's 5, 20, 80, 320. We've just done that one together as an example. So now you guys would be starting on B. What are we doing each time?
Then B, you multiply by 3.
Exactly, Sinotando. Perfect.
Yes, ma'am. So 27 times 3 is 81.
It is indeed. That's very good. Well done.
Then 81 times 3 is 243.
It is 243. That's good. Well done. 243. And then what are you going to have to do to 243?
729.
It is indeed. Well done. Good, Sinotando. So what would you say the rule is?
Multiply by 3.
Multiply by 3. Well done. Lovely. Good job.
Thank you, ma'am.
Okay, so now you try C, D, and E by yourselves. And then I'm just going to be quiet for a couple of minutes and let you work, and then we'll talk about the answers, okay?
Yes, ma'am.
All right.
Ma'am, I'm back.
Okay, Pabalo, that's great. You're going to do C, D, and E on your own, and I'm going to give you 5 minutes, and then we're going to talk about it.
Ma'am, do you still have a poll today?
Yes, we will still do the poll today.
Yes, ma'am. Thank you, ma'am.
Okay, all right.
Ma'am.
Yes, Panolo.
Ma'am.
Ma'am, my phone is showing people's faces, not the work.
Oh, Panolo, that's not good.
Is there a smaller screen, like at the bottom of? Because I think you swapped the participant screen.
Ma'am, Ma'am, here I can see Ngosnati and Nima. Oh,
Ma'am.
Okay, let me help you in the chat, okay?
Yes, ma'am. Ma'am, can I please ask a question?
Who's talking?
Anati.
Okay, Anati, what's your question?
My question is that must we do 2?
If you want to, if you think you can, that's fine. I'm just waiting for everybody to do number 1, but that's fine.
Okay.
Always nice if you can extend yourself a little bit.
Thank you.
Okay.
Ma'am?
Yes?
Ma'am, for cubes, ma'am, I really don't understand cubes.
Okay, when you say you don't understand cubes.
Ma'am, because I think, ma'am, the way I do it is that, like, for example, there will be a number, for example, 2, then a 3, a small 3 on top. Isn't that cube?
Yeah, that is a cube, absolutely. So that's exactly what we were doing earlier. All right, so when we said 1 by 1 by 1, that's 1 to the power of 3. And then when we said 2 by 2 by 2, that was 2 to the power of 3, which gave us 8. And then we said 3 times 3 times 3, which is 3 to the power of 3, and that gave us 27. Absolutely, that's exactly what we were doing.
Ma'am.
Oh, thank you, ma'am.
Okay. All right, so a lot of you seem, yes.
Please help me with D.
Sure. Okay, so there seem to be a couple of people who've got questions and other people that are done. So I see that our time is sort of running out. So let's just go through this very quickly, all right? And then we can talk about question D while we are at it. All right, so if we have a look at question C, can you see that this number, the significant figures, are getting halved? All right, and we're keeping the 2 zeros on the end. So now that would become 400. This would become 200. This would become 100. All right, so what we are doing here each time is we are dividing by 2. So that means it would be a geometric pattern. Now let's have a look at the next one. Okay, so if we look at these two numbers, okay, what's the relationship between them? What would I need to do to 60 in order to get to 120? I would have to double it, wouldn't I? So now I'm going to go back and I'm going to look at 15 and I'm going to say, well, if I double 15, I'd get 30. And that makes perfect sense because if I double 30, I'd get 60. So now I'm going to have to double 120, which means I'm going to get 240. And then I've got to double 240 and I would get 480. And if I doubled 480, I'd get to 960. Okay, yes, absolutely. All right, so here we are multiplying by
2.
By 2. Good, Sinatando. All right, now let's have a look at E. So we've got 41, 4,1, 0,41, 0,041. Are our numbers getting bigger or they're getting smaller? Yes, Tyler, quite right. Tyler says we are dividing by 10. Good, Tyler, we are dividing by 10. That's quite right. So here we are dividing by 10. So what's the next number going to be? 0, 0,041. Yes.
Can I please go to fetch my jacket? Actually, it's kind of cold.
No, that's fine. No problem at all. All right, we're going to do our poll soon anyway. Okay. And then here, if we divided by 10 again, we'd end up with 0,00041. Okay. Somebody said, ma'am?
It was me.
Okay, Anati, what did you want to say?
I wanted to ask if I could answer 2D.
Go for it. I tell you what, why don't we do that right now? What would you do in 2D?
I would add in ones.
You mean you're adding 1 each time?
No, adding 1, then 2, and then 3.
Okay, so are you saying that first we need to add 1, and then we need to add 2, and then we need to add 3, and then we'd add 4, and then we'd add
5.
Okay, so then what would the next number in the pattern be?
You would add 6, and the number would be 23.
And then you'd add
7, and the number would be 30. And then you'd have to add 8, which would be 38.
Okay, so now I want you to tell me. That's very good. Well done. And Nati, is this an arithmetic pattern or a geometric pattern?
Arithmetic pattern.
It's not an arithmetic pattern. Why is it not arithmetic?
Sorry. It's a geometric pattern.
It's not a geometric pattern either, Anati. Okay, it's not arithmetic and it's not geometric. Okay, because we're not adding the same amount every single time. Okay, we're adding a different amount each time. So this is neither arithmetic nor geometric. Okay. All right, I think we need to do the poll now. Is that right, Kat?
Yes.
Okay.
I just wanted to say that some had a bit of a mistake because 11 plus 5 is 16 and not 17.
Oh, yes, quite right.
Yes, thank you, Fatima.
Thank you.